Hi, everybody. Thanks so much for joining us today. My name is Jeff Bund. I'm head of business development for Vario Technologies here in the US. And I'm really happy and I guess I would say proud to be talking about HeadWall, which is an application that was developed by our partner, ITI Systems. Um, what HeadWall basically is it allows for the full functionality of a command center, watch floor, or other large video screen application to be packaged up in the form factor of a virtual reality headset. What this basically means is that what was previously presented in, 10 plus video screens, all of that visual information can be taken in by a user in a much smaller form factor, much smaller footprint, and in a much more convenient way. The other thing that HeadWall also encompasses is hardware functionality. What this means is that in the Unreal application that they've developed, hardware that's traditionally used in a command center can also be controlled in a software application. This would include things like VTC for video calls, camera directions, or input sourcing, or any other functionality that a user would be used to in a large command center. So roughly speaking, what we'll be going over today is what is HeadWall? What are some of the key technologies that enable it? We're really lucky to be joined by some experts from Pershing Technologies who've been designing command centers for quite some time. And then we'll look at some key applications for it, some use cases that are good fits for this application, and what are the advantages and what would be the return on investment? Why would someone use HeadWall? And what should they look into while they're adopting it? And then hopefully we'll leave some lengthy time for a Q&A. We seem to have really good participation in these sessions. So I'm really excited in what you all will ask us when we're done. So just to introduce the panel a bit, we're joined by Matt Jackson and Emily Hay from Pershing Technologies. They're subject matter experts in command centers and super knowledgeable in designing these systems. We're also joined by Mark Templeton, VP at ITI Systems, and finally, Adam Wiener, president of ITI, who's going to talk through a video and talk a little bit about the underlying technology here.
Thank you, Jeff. Really happy to be here. Excited to begin to release this new technology innovation to the world. Just a brief description of what HeadWall is and why ITI set out to develop this technology. ITI is a systems integrator that's focused heavily on command centers for the past decade. We've built the traditional command center for our customers, both commercial and government around the world. And we saw the problem that began to occur really in earnest in March with the need to social distance and the need to sort of allow people to separate where they're working from in these command centers. And we set out when we were locked down to begin to develop a technology to allow us to bring the functionality of a command center and a video wall into a head-mounted display, an HMD. And through a lot of support from Vario, we were able to arrive at a solution that we think is pretty compelling. So the best way to start probably is to show you the video of some of the capture that we've done, and I'll talk over this. And as we're doing this, I'll just say that we have a demo environment of this actually working in our facility. We're talking to you from the lab floor, and the product is available to be seen in person, and you really can't get the full experience from a webinar. So feel free to reach out to us after this is done, and we'll be happy to bring you in and show you how the whole thing works. So this is actually a Vario product, a little bit of a classic. I believe that's a VR1 there, and basically what you're looking at right now is a set of media streaming textures inside the VR environment. And what a media streaming texture is a TV, basically, inside your environment. So what we built is a way to route external sources in 4K into that HMD. And what we're trying to show you there is resolution. And we've also built in the ability to do KVM USB routing so that you can control these devices from inside the headset. And what you're seeing right now is a full VR version of this, and in a second you're going to see XR. So what's happening here is routing some sources. You're going to see a preset saved, and that's both layout and source routing information. Then you're going to see it recalled. So that's, you know, normal, typical command center type of functionality. And this is the great part. Because of the XR1, we're able to superimpose these displays through the video see-through technology so that you can see your hands. And what we found is that when we were developing this, it was cool to work on it in VR, but you needed to be able to touch the keyboard to be able to control a web page. So we ported this over and integrated Vario's functionality to allow you to see your hands. And what that means for a command center operator is that you can actually use the system and keep the headset on if you need to. The way that command centers work is, you know, these operators have to pick up the phone, they have to type an email, they have to, you know, insert their CAT card into the CAT reader, and unless you can see your hands, it doesn't work. So until the release of the XR1, you know, which combines both high resolution and you know, video see-through technology, you couldn't do all these things. If you try to do this on some of the other products that have, you know, some sort of video, some sort of see-through technology, some sort of augmented reality technology, you don't get the resolution necessary to view the critical data. And it's the combination of those two things that make it possible. So now we'll talk a little bit about the key supporting technologies that made this this method that we've put together, that we have a patent pending on, you know, work. It's basically an integration of several different things and a little bit of software that we wrote to make it all tie together. So one key function is the Vario headset. High enough resolution to give you the same ability to see what you're looking at that you would have with 20/20 vision. And Jeff can speak to you about that all day, but that's, you know, 60 pixels per degree of angle in the focus area, same as 20/20 vision, basically, in terms of resolution, and then the video see-through technology. The other two things that are on that little diagram are NVIDIA. The Ampere chipset is one thing, and you know, both the RTX 3090 and the A6000 will be sort of the driving force behind decoding streams in the environment. And we're going to talk a little bit more about how that works in a second. And the last one is SRT. So what we're doing with HeadWall is we're replacing your video wall with some HEVC encoders and our plugin that decodes those HEVC streams. And basically what you end up with is a protocol that applies a good amount of compression that's still pretty good quality in terms of the way the video looks. And also with SRT, if you don't know what that is, it's secure, reliable transport. You get this AES, you know, private key encryption of the stream, and then you also get the added stability over sort of less than ideal network connections over the WAN, basically. So SRT is a technology that Haivision developed and then started the SRT Alliance. So more and more manufacturers are picking this up, and our solution, with the exception of the Vario headset, is manufacturer agnostic. So it doesn't matter what you've got in your head end. It doesn't matter how you're controlling your command center. You know, HeadWall is built to be able to meet the industry where it is and sort of drop into these environments without a lot of work. So we'll go to the next slide. If you work in AV, I think that we've got a pretty good split of pure VR people and some AV people on the call. So if you're in AV, this is like about as simple as it gets in terms of a logical diagram. You've got, the way that it works is you've got sources on the left. These are like real video sources on HDMI, SDI. It could be an RTSP stream. It could be a security camera. It could be a signage player, a VTC codec, basically anything that you would normally plug into your matrix switcher. You take that into your matrix switcher, just like you would in a normal command center. Also, you know, USB KVM, USB HID for CAT cards, that kind of thing, into your matrix switcher, into your AV over IP encoders and decoders, whatever you like. Out of that, you come into video wall processors. And we're manufacturer agnostic in this space too. What we're showing here and what we're doing in our lab is actually windowing processors. So basically, 4 4K inputs, 1 4K output with each of those 4 inputs tiled into the image. And then we take that and we encode it. Right now we're primarily using HEVC and SRT. And then we take that to the network. And that little blue box there could be a lot of things, and your environment is going to require a variety of different approaches in this space. But the key to it is that off of this AV network, you hang a control server, and you connect back to the control system. In our lab, it's a Crestron CP4, and basically our application inside the headset allows you to create buttons and to assign syntax to those buttons and to open up a TCP on a port back to that control system processor, and then when you press that button, sends the command back, and then the control system takes care of understanding what the environment is doing and making the right things happen at the right times. A video route, a video wall layout recall, pan tilt zoom of a camera, dialing a VTC call, any of those things. So that, in a nutshell, is how it works. And we're happy to say we've got one built here. So if you want to see it in person, let us know. The next slide is pretty important also in terms of functionality. So Matt and I have spent many a long night working together on control system programming. Matt is sort of an expert in that area, to make these command centers work the way that they're supposed to. And a lot goes into that. And what we've tried to do is not make a system that requires some sort of overhaul of your control system, but ties into your control system and basically allows another point of signal input for controlling devices. So our API is, just like I said, you can create a button in the Unreal environment, you can assign the particular syntax you want sent when that button's hit, and you point it at the control processor, and you're good. With obviously some control system programming to happen after that. But that's the gist of it. And one other thing that's really compelling that we're super excited about is most control systems today are run off of touch panels, and most touch panels have some type of web browser-based control method. So you basically would enter the IP of that control system processor, and the same screen that would be on the touch panel would pop up on that web browser, and you would be able to control it from there. And because of the native browser integrations with both Unity and Unreal, we're able to use that functionality. In our lab, it's Crestron, so it's going to be an X panel that pops up in that page, and you can have the exact same touch panel that you use in your control system environment appear in the head-mounted display, and it functions in exactly the same way that it would in the web browser. So again, a lot of effort. We're an AV integrator, and we sort of understand the complexity of what has to happen in these environments, and because of that, we've kind of built this with the AV integrator in mind. So with that, I'm going to pass it along to the next slide. And in this one, one of the reasons that we built this, as I talked about earlier, is to deal with some of the problems we have in command centers. Some of them we've had forever, like viewing distance and seating arrangements, and others are new to COVID, which is like we have to move everyone out of the command center for a brief period of time and go across the hall somewhere else. How do we do that? So with that, I'm going to turn it over to Matt and Emily to talk a little bit about command center design and what some of the applications of this technology might be.
Thanks, Adam. As mentioned earlier, my name is Matt Jackson. I'm the president of Pershing Technologies, and at Pershing, we specialize in designing and implementing command and control center environments. We do somewhere between 10 and 15 of these a year, so we're pretty accustomed to what the needs are of each of these environments, and 3 things really come up on a pretty consistent basis. The 3 are force protection, user experience, and space planning, and we're going to talk a little bit more about each of those. So to begin with force protection, the goal of any command center is to try and consolidate as much information into an individual environment as possible. And then 2, the second goal would be to provide that information to the key leaders, the senior management, and the decision makers so that they can make timely and informative decisions with the information presented to them. So when you talk about force protection, obviously you want to get as many people in front of that information as possible. But these command centers are typically in not so great places, right? They're either in a conflict zone, or maybe a natural disaster area, or God forbid, a global pandemic area, right? So it's becoming a larger and larger trend to try and remove the physical footprint of the command center somewhere where it's A, safer, and B, where our people can be out of harm's way when they're physically inside of the command center. And that's what HeadWall does a really good job of, and why we're so excited about it, because now you can have two people, one in a very safe environment and one, in the mix on the ground, ready to execute decisions, both looking at the same thing, both making decisions on the same information at the same time. And that's a really powerful experience, and one that our customers are very excited about and moving towards in a pretty rapid succession. So from here, I want to get over to Emily Hay to talk about user experience and space planning. Thank you.
Thanks, Matt. Hi, everyone. My name is Emily Hay, and as mentioned, I am the Vice President at Pershing Technologies, and I'm responsible for the design and engineering group, where we design operation centers for government and civilian clients around the world. As Matt mentioned, user experiences is one of the most critical elements to a command center. And typically the content that's displayed on these video walls is what we would call inspection level content. And that means complex maps and spreadsheets. You can see on the graphic on the right, the green area is the recommended seating for inspection viewing in this particular operation center. And you can also see that 2/3 of the seating is outside of this recommended viewing area. And that's not an unusual occurrence, especially when we get to the space planning discussion. This problem is eliminated with HeadWall because it brings the content to the viewer at a high resolution. So it doesn't matter where the user is located, either in the space or outside of the space, they'll always have a front row seat. One of the other areas where we see HeadWall making a big difference in command center design is in the space planning. Typically, when we design these command centers, the end user's desire is to cram as many seats as possible into the allotted space in order to plan for a real world event, where the desire would be to have everyone in the same physical space, allowing for greater collaboration. We spent a lot of time trying to determine space adjacencies and seating assignments, while also trying to keep the space flexible for future modifications and changes. So a lot of effort goes into that. Then when it's all said and done, typically during day-to-day operations, these large flexible spaces that we've designed are only filled to 10 to 20% capacity. So there's a lot of wasted space and wasted cost attributed to the worst case scenario. So HeadWall can really make a difference for these projects. It allows the users to collaborate if and when it's needed. So we don't need to over design the space for the worst case scenario. And instead we can design it for a more comfortable day-to-day environment. Also, with the onset of COVID, we are seeing more and more that the users can't be in the same space at the same time. And I worked on a project recently where we were asked to design in sneeze guards around every desk, which you can see there on the right. This certainly doesn't inspire collaboration, and it would certainly affect sight lines, as we talked about earlier. So with HeadWall, the users can be socially distanced while still collaborating in real time. So with that, I'm going to toss it back over to Mark, who is going to talk a little bit about use cases and return on investment.
Awesome, thank you, Emily. We've kind of centered the conversation thus far kind of around the traditional DoD command center environment. This could certainly be used training in that environment as well, giving operators a real life platform to train various scenarios in the exact environment they're going to be operating in. But beyond just DoD applications, this technology is really applicable to any command and control environment. So it could be an emergency operations center at the federal, state, or local level, emergency operations centers in a utilities environment, network operations centers in enterprise or government environments, securities and crypto trading applications. An emerging application we're seeing quite a bit is autonomous vehicle command and control. And this is particularly neat for that application in that, that secure camera feed is able to be natively decoded within the HeadWall environment. So that's another great application for HeadWall. And then also, the security operations center environment. Again, camera feeds are being encrypted and streamed already. So they can be ingested into the HeadWall environment, decoded at human eye resolution, and provide the same or better user experience than they would have in a traditional system design. And some of the benefits we've already discussed. The safety aspect is absolutely huge. The Vario human eye resolution basically gives you the lowest cost per pixel versus traditional large scale video wall deployments. I believe it was Matt who mentioned a trend of getting folks out of harm's way in dangerous environments. There's also cost associated with that as well. So to be able to provide someone with the control environment from their space or a remote, more secure space, absolutely a compelling benefit. And then probably the biggest cost benefit is the reduction in space required. Emily mentioned, these spaces are often underutilized. So you can build a space to suit your day-to-day needs and then scale it as your needs change or the situation changes. These benefits together provide a very compelling total cost of ownership and return on investment utilizing HeadWall. Jeff?
Yeah, so that's all we had as far as a formal presentation. What we'd like to do now is open it up to a Q&A. There's a button at the bottom of a very easy to use Teams application that would allow you to put in questions into a chat or messaging application. And so we could field some of those now. Well, I know one question that came up when we were talking about this is that, like, what would be the considerations in terms of, like, let's say I wanted to install a video wall now or use this application, use HeadWall. How would I go about scoping that, or what would be the first steps in terms of getting that going?
Yeah, that's a good one. I'll take that one. So as I was saying in the initial discussion, HeadWall was built to act as an extension of your existing video wall or to be able to mirror your existing video wall. And in terms of the infrastructure that's required, you would approach it in the same way that you would approach adding an additional display wall to your environment. It would begin by, selecting the group of designers that you want to look at your infrastructure and determine what's needed in terms of additional outputs off your matrix switcher. And from there, you would go through the program of requirements process. And somebody like Emily would be the person that would put together that program of requirements and then turn that into the engineering documents that are needed to build it. And then on the HeadWall side of things, really once we have those inputs available to us, the outputs available to us from your video wall processor that you're going to use for HeadWall, you basically meet with us and we further elaborate on what the functionality inside of the application would need to be in much the same way that you go through a design process in creating a control system for your environment today. So really, if you're in the AV industry, and I know some people on this call are, it's not any different than the way that we approach anything else. It's really exactly the same thing. So that's how you engage, to look at HeadWall in your environment.
So yeah, we have a bunch of questions coming in now. Someone asked, what's the difference between HeadWall and Facebook Infinite Office? And I can kind of start off on this. I'm not that familiar with Facebook Infinite Office, but one thing I know off the bat that separates us from using a Quest or Facebook or any of those other applications is that this whole thing can exist in a secure environment. So Vario products, for example, don't need to have any other software that does something like phone home. It doesn't ship with a store. You don't need to have a profile. So there's a bunch of things that are blockers straight off the bat from using more consumer products in this environment that Vario does really well. And like one thing that Adam touched on that I also would double click on is that Vario very much is used to interfacing as a hardware supplier, like the other hardware suppliers have been working in this space for a long time. So we really get behind the product. We will support it in a way that a lot of consumer device manufacturers aren't able to. So we can really roll up our sleeves and work in this environment in a way that others can't. And then I'm speculating here about Facebook Infinite Office, but I would say that that also probably doesn't have a hardware control aspect to it as well that would allow you to control your resources.
Yeah, that's what I was going to say. So the thing that's happening here is, it's kind of the difference between something that is sort of public cloud based and something that you would do over, a type 1 encryption device through a GRE tunnel. It's just sort of a totally different method of getting the video to the head mounted display. So what we're doing is we're taking, up to, you could just pick a number. It depends on the number of inputs available on your matrix switcher. It could be, 1,280 individual PCs or video sources in your environment. And then being able to know that those devices are in a secure space, connected in a secure manner, and that to get to that PC and view that content, what you're doing is actually controlling the matrix switcher in that environment. You're not, doing some sort of VNC screen scrape of a particular PC that's in the cloud, or sharing something from within your computer's graphics card and rendering in. There's actually a lot of applications that probably look similar to what HeadWall is. The sort of key is that the thing that I would say that's key to look at is the diagram that we showed. So we're talking about like a hardware integration for a secure command center environment, where the idea of Facebook at all is it sets off insider threat alarms all day, and it's not something that really we can use in our space.
Yeah, we have another great question here. What data sources can you use to push into this, and what are the limitations?
I wish I could ask a question to the question, but I guess
Sure.
I can't. We'll see if we get a response. Can I do that?
Sure.
So when you mean data sources, are you talking about control data?
I have another good question then as well, from Vaughn. Hey, Vaughn. Have you considered blending this with 3D content in addition to 2D video streams and browser windows?
That's a good question. We are not. There's a divide right now in the command center space. We're not necessarily working with a lot of 3D right now. I see that once we begin to roll this technology out, it's going to be sort of where I think that AV and the VR communities are going to start to meld together so that we can start to hear ideas like that. I think that I speak for most people in AV when I say that the idea of doing something like, what the auto designers do in VRED inside of a command center environment is super compelling. I think that if you think about, the defense application, the sandbox, being able to bring up a sandbox inside your AR environment is super compelling. We've been working on something like that. I think it's a great idea, and I look forward to seeing where the community tells us to take this thing. So yeah, I think it's great.
Yeah, one more great question as well. Can anyone on this panel compare how long to technical obsolescence between a virtual and physical command center?
That's an interesting question. So I think the answer to that is that we're using a PC and a graphics card to get this done ultimately, and we're using encoders and decoders. We're using encoders and we're using a software-based decoder. And in terms of obsolescence, it's the headset, based on Vario's data is something like a 2 to 3 year, MTBF, something in that range. And we would want to see an actual video wall in a command center last longer than that. But I would also say that the headset itself is significantly less expensive than your video wall. So what I see happening is the life cycle on this technology is going to be more akin to what you do in your desktop environment, and we'll start to replace hardware and have updates happen that are modular. So you won't rip out your entire command center head end. Your matrix switcher will stay. Your video wall processor will stay. Your encoder will likely stay, but we might upgrade your PC and your head-mounted display when Vario releases the whatever it is, the XR2. No, I guess it would be something else. I don't know how that. Go ahead.
I was just going to say, I don't think the goal is to eliminate the real world command center. I think that's the benefit, especially of the extended reality, because you can meet the command center where it is today. And anybody that works in government or DoD type environments, they don't typically like to be on the bleeding edge, and we can't be on the bleeding edge because of IA, security concerns. So this is a way to kind of dip your toe in the water and advance the technology without completely ditching a real world command center, which they know and are comfortable with, and is the traditional way that they operate. So it's a way to kind of push the envelope without completely trashing the old way and bringing in a new way.
That's a really great point. Like I think that's actually a great way to look at it, because the reality is that if you want to try this technology out in your environment, you have an existing command center. It's basically some additional outputs off your matrix switcher, a video wall processor, and a couple encoders to get this done. That's
yeah, very low risk.
It's low risk, exactly.
Yeah, I've got a question I'd like to answer. What, if anything, are you doing with the eye tracking available in the XR1? And I think that the answer to that is there's a lot of things that are potentially available in the future or that could be implemented by ITI upon request. So one thing off the bat that our headsets do very well is you can use the eye tracking as a cursor, or basically as an output. So if you wanted some kind of mouse over mouse on command to be implemented using the eye tracker instead of a mouse or in addition to a mouse, that's something that could be done very, very well and very easily within Unreal that ITI could implement here. And then one thing that we're sort of dipping the toe in is the potential for continuous authentication. It's a bit of an open space right now, but I don't know if there's anything you guys want to comment on that.
Sure. So this is a feature that we're hoping to add soon. The eye tracker works using a camera in the HMD, and that camera gives us an image of the iris that is, we believe, good enough to enable authentication, biometric authentication. And we sort of envision as a roadmap item to be able to make it so that you put your card in the card reader, you put the headset on, and you're able to authenticate both with something you have and something you are, and that's valuable in a lot of cases. I will say I'm gonna temper that by saying that this is not something that we're gonna have next week. So it's the way that that's done is with near infrared light and cameras, and we're sort of working with Vario right now on how we're going to make sure that we're getting an image that's a high enough quality to yield the level of accurate authentication that we need to have something that we can say works. I don't think that we're quite there yet, but it's a great idea. And on the eye tracking thing, I'm going to just ramble for a second. You can cut me off whenever I.
No, go
All right. So the eye tracking thing, one compelling thing that we really like for training applications. If you're working on training command center operators, watch floor operators, and you want to stand up an environment that is basically exactly the same as what you're using in the real world, the way that we would do that with HeadWall is we would build the head end of your command center. We would have a matrix switcher, all those things that we talked about. And instead of putting PCs connected to the network at the input, we would put some type of media server, like, you could do something simple like a bright sign player, and you could record the various scenarios that would occur and have the API tie back to that, so that when an operator does a certain action, the next video cues and plays at the right time, so that we can work with you to build scenarios and train your operators and have the environment react in the right way. And what's beautiful about that is instead of having to reprogram your gaming engine or reprogram your game for every scenario, you basically load video content into media players and put triggers in there so that you can hit it with the API and cause the next thing that needs to happen. We think that that's a compelling use case, and we see that as providing an opportunity to take a real command center and add some additional input capability and then run those scenarios in the actual command center if you need to. So that's one potential application that we've been thinking about, and we have the API built to do that today.
Well, and in the training environment as well, with eye tracking, being able to measure where the operator's focus is.
Oh yeah.
Make sure they're focusing on what really is important in that scenario.
Yeah, and in Jeff's last webinar, they talked a lot about the ability to take that data from the eye tracking that we could pull from Vario's API and compare a novice operator to an expert operator by where they're looking and for how long when certain things are happening in the scenario. And by getting that data, you can start to figure out why operators might not be catching on to what they're supposed to do at the right time. And the coaching that you can provide and the performance in the training that you get is pretty compelling.
Yeah, we're getting a lot of great questions. Thank you so much, by the way. This is wonderful. 2 questions came in involving intercoms. Is there an integration for an intercom or other audio communication between headsets? I can speak to this a little bit from a hardware standpoint. So Vario hasn't locked into any specific audio or microphone setup, but our headsets do have a microphone jack. You see, that's located behind the face mask. So we're compatible with a series of hardware, and we can provide that on request. And then we also have some people who have built custom push-to-talk intercoms that are compatible with our headset. But how that integrates with the application, Adam and Mark could speak more to.
Yeah, so we do a lot of intercom stuff in command centers now, and we would do this in the same way. The one thing that I will say, one of the concerns that we have about the headset in general is that this is not something that somebody's going to be able to wear for 10 hours a day. We sort of view it as something that somebody's going to put on and take off as needed. And the ability to put an earpiece in, a wired earpiece, and connect it to a normal, audio DSP that enables intercom within the command center watch floor and can then tie in to a VoIP line or, a video conferencing system. All that functionality happens in a traditional command center in the DSP, and it wouldn't be any different here. We can also, if you're using something like ClearComm or Readle to do your comm, they have an API that's fully functional that we can communicate with as well.
Here's a good one. What would it take for a financial day trader to be able to try something like this?
Well, for financial day trading, our application would require a set of computers that you were going to use to access various things that you need to look at, and we would basically build the same infrastructure that we've just talked about. So you would end up with something like a command center, or like financial trading floors. That's probably typical. If it's something that you're using in your home, it's maybe a little bit of a stretch, but there is the possibility to remotely, if you're working for a company, like if you are trading for JPMC and they have a set of computers that you have access to, we can definitely tie that into this system and then encode, send out over a secure encrypted stream, and then you could pick that up in your home potentially.
So if the hardware exists set up anywhere, you could access it remotely using this application?
Yeah.
That's very cool. I did not know that. How do you foresee the blending of VR and AR, especially for people who will be co-located in the same physical location? This is a very abstract question.
Could you read that again?
I think what this person is getting at is that if you have multiple people, I think what they're picturing is that there are people in a command center also with a headset on or working in the same office. And how would you navigate like people basically looking at the same information at the same time, but from different vantage points?
So the viewing angle to the media streaming texture inside the headset remains the same.
Well, I think like, what if you and I both have headsets on, right?
Well, it becomes a personal video wall at that point. So instead of watching, seeing what's on the video wall and having that be a common experience across the command center, every instance of HeadWall, whether it's in the command center physically or remotely, becomes a personal video wall experience for that operator.
It can, yeah. So you can either mirror your existing video wall so that whatever the video wall processor outputs are feeding our encoders, or you can create more matrix switcher outputs so that everybody gets their own ability to route. So you can either, and we can actually tie the two back together. So if you, the first option where would be like, you only see what's on the command center wall. And if you change a route in the headset, it actually changes on the physical video wall. The other integration is basically where you have your own video wall that you can route any sources that you want without affecting what's going on in the space. And it kind of depends on what your use case is. If it's somebody from leadership that needs to look in and see what is going on the wall and make some changes for people, that's the mirrored approach. And if you're doing the extended approach, we can absolutely put in an API command to sync you back up to what the command center video wall is doing. So you can kind of do both if you do the extended, but if you just do the mirrored, there's a physical layer, like a layer 1 difference in the way that it's like wired up. So
there was another similar question, Adam, there about if you wanted to have multiple people in the same environment, would you have to set it up in every headset, or is there a way to share a setup? Would that also just be an API call to the virtual environment where you can quote unquote share? You're not actually in the same environment, but the API is tracking the routing?
Yeah, you can definitely do that. And basically, if you want to all be able to, if you want to be able to send a source to somebody else's headset, is that kind of the question, Emily?
I think so. I mean, that's how I'm reading it. They want multiple people in the same environment collaborating, same virtual environment collaborating.
Absolutely. So, it's just about number of matrix switcher outputs, number of video wall processors. It's just the same count. So it's like, picture it. If you gave each person their own individual video wall, if I wanted to take, the video conferencing codec output 1 and send it to my video wall, and then I wanted to have you take my video conferencing codec over to your wall, that's just an API call. It's just a matrix router switch, and that's a something that's pretty easy to do in our system.
Great questions.
Yeah, these are great.
Good questions.
Here's one. Would this work in a hybrid security command center as it also includes physical security?
Yes,
Okay.
absolutely. So the hybrid security environment, one of our fintech customers, one of our largest customers, has what they call the JSOC. It's the Joint Security Operations Center. It's not the JSOC. It's their combined cyber and physical security center. And what they've started to do is locate these all around the country so that they can fail over one to the other. It used to be more centralized. And what's great about this is that the cyber guys are, dealing with something where they need a lot of data quickly. They can, you can have your normal video wall, and one of the cyber guys needs to inspect like a bunch of stuff all at the same time. They can pop the headset on and bring that up without disrupting what else is going on. The other thing that happens in those environments is you have two separate emergencies happening at the same time. So you have a physical security scenario and a cyber scenario happening at the same time. And that's when chaos starts to ensue, when you need more space and more people. And in these environments, I picture having a couple headsets where people can break away and take a look at the security cameras without having to bring maybe the CEO's home, his driveway up on the command center wall is valuable. So yeah, I think that those types of environments are really what this was built for. Also, if you want to have somebody viewing something that's very sensitive that you don't want on the video wall, or you want a special group to look at something, you can utilize this technology, and you can limit what routes are allowed to be made to our system. So, if you want to keep certain data off the main video wall that's viewable to everyone in the command center, but you want that to be available to the VR headset only, that's a possibility as well.
That's great. Can this be used in various sites all over the world, and the same sources get routed to any user with respective permissions and privileges?
Yes, that's the beauty of the whole SRT thing.
Okay.
That is the way that it will work. So the constraint is bandwidth, right? What we're doing is we're taking, a 4K stream, and we're encoding it HEVC. So we can get it down to about 20 meg at pretty good quality. When you get 8 of these together, you're talking 160 meg. And these are unicast streams, so you've got to kind of multiply that. You start to need some bandwidth. But our customers, in the financial industry, if you tell them that you need this kind of bandwidth for this application, it tends to be something that they can entertain. And on the LAN, local, if the bandwidth's not really a concern. I mean, you can use 10 gig or 40 gig uplinks or 100 gig uplinks if you have to. So the answer is yes, with the constraint of bandwidth.
I have a sort of simpler question, but we have some more kind of, I guess, business-based questions. Or is there a way I can see a demo of this without travel upcoming? Like, how do we demonstrate this? Is there a way?
Yeah.
And I think no is an okay answer. But
No, there is a way. Okay. So
Okay.
behind me, you're here in the lab. So over
Yeah.
there is that thing that I showed earlier in the diagram. It's the physical version of it sitting right over there. And what you would have to do is get with us, and we would need to just make sure that you were in a location where you had sufficient bandwidth. And we have sufficient bandwidth to do, we can do up to 32 simultaneous streams from this location. And basically, we can plug PCs in for you, and we would need to send you some hardware, a headset and a computer with our application loaded, and then we would kind of walk you through setting it up and getting the stream subscribed. And yeah, so that is going to be coming shortly. We're not quite there today, but we're 30 to 60 days out from being able to send you a headset and have you look at that over the web.
Here's a good one. Are you able to use MS Teams application inside HeadWall?
Microsoft Teams?
Yes.
The greatest invention ever to reach the video conferencing world? Why, yes, of course. So the way you would use Microsoft Teams in the environment is, I showed that, you've got a bunch of PCs connected to a matrix switcher. You would have the Microsoft Teams image running on a particular PC. You would route that PC to a window inside your headset, and you would route KVM mouse and keyboard control to your mouse and keyboard, and you would type in the person's credentials that you wanted to call and click call. And audio and video can all route, dependent on the hardware in your environment. That all works.
And would that would, I think, work for any conferencing application, right? Like if you can make MS Teams work, you can pretty much make any conferencing application work.
So yeah, and what I would say is for the purposes of what we're talking about here, MS Teams is like a soft codec based video conferencing technology, like Skype, like Zoom, and then what we don't use these things that often. Well, that's not true. Hardware video conferencing is still a thing, and we much prefer it because it tends to be more stable and perform better and more reliably, because you don't have to worry about things like USB, UVC drivers and registry, Windows registry. So any video conferencing platform that has a video output and audio in and output and video input can work. And we could even make the eye camera go to the far end. You don't want that, but we could do that. Yeah, no problem on the video conferencing stuff.
Okay. Would we want to get into any discussion about costs? We're getting some questions about that, like high end or low end, or what the process would be expecting something like this out.
It's really very variable. Like our product, you know, if you know, the Vario pricing for the headset is one thing to consider. That stuff's publicly available on the web. I don't know off the top of my head what it is, but I think something like $12,000 for a VR2, or I'm sorry, an XR1, and that's kind of what you want for this application. And then our software licensing model works based on either a single license, if you want to buy up to 4, and then we have a site license that will give you an unlimited number of instances that you can deploy. Then you need a computer to get that to work, and you need a couple other peripherals. The thing where it starts to be difficult for me to tell you how much it will cost in your environment is you have to tell us whether you want to mirror your video wall or extend it. If you're mirroring it, we can potentially do some sort of distribution amplifier infrastructure to get that done. If you want to extend it, we've got to look at your matrix switcher frame and determine whether or not you've got enough available outputs to get this done. You've got to buy an additional video wall processor if you want to do the extended approach. You know, think of it like this. It is not any more expensive than adding an additional video wall to your space. It is less expensive than that.
And I think this is Emily, I think it's one thing that you should probably consider, even if you're building physical command centers today, that you plan in the infrastructure, you know, like we always do, future growth for this type of application. And then you're kind of planning for being able to add on when, you know, budget allows, but it's something that you can incrementally grow. So you can start small and then expand it as it gets more use and gets more traction.
Is there just anything in this except 8K video streaming architecture?
What's that?
Like, does HeadWall accommodate 8K broadcasting streaming?
So yeah, again, it's a bandwidth thing, right? So HEVC will do 8K. The thing that we run into is that, you know, find me a manufacturer that's making an 8K hardware encoder right now for HEVC, and I will deliver that to your headset. But, you know, we'll start to see that more. And one of the things that we did with this, you know, we're talking about H.265 is HEVC, right? And we decided to use that because the compression will give you a high quality stream at lower bandwidth, but it also has, you know, that 8K capability. And there's nothing in what we're doing that's going to make that not possible. So what I'd say about the 8K thing is that we are 8K ready. I don't know that the industry is 8K ready. I don't know that the AV industry is 8K ready right now either, for that matter. I think Emily would probably agree with that.
Yes.
And then we have a couple questions about key benefits. What are the key use cases? And I think that's probably a good way to just like recap. And then we'll end it. But what I would say is that we're highlighting the use case here with virtual command centers, but there is applicability basically anywhere where there would be a large scale video wall, and then some. So the key value adds are the flexibility of working spaces, keeping people out of harm's way, or at least having geographical flexibility and the risk mitigation, having distributed teams. And then also Mark could talk about anything that maybe I missed with that, like if there's like display performance advantages.
Yeah, I mean, it talked a little bit about cost per pixel. I mean, you know, large scale video walls can be exceedingly expensive. So it is quite feasible that you could implement, you know, many instances of HeadWall for less than the cost of a traditional video wall, or adding on to an additional video wall. And
Yeah,
yeah, absolutely. And then the application is really, I mean, as you said, any command and control type environment. So be it military command centers, emergency operations centers, network operations centers, anywhere where you need to visualize lots of information at once, or need to provide custom visualization for a user or a set of users are all great applications for HeadWall.
Yeah, great. I think that's a good probably note to end on. And I think these questions are great. And if they're any indicator of what everybody out there is thinking, you should really reach out to us. Please contact us. We'd love to field more questions, and we'd love to get into a dialogue about how this could be used, how you would use it, and what your concerns are. So thank you very much for joining us today.
Thanks a lot.
Thanks, everyone. Have a good day.
Thank you.